Morning students, welcome back to operating system class. Today, here I am going to explain scheduling criteria. Okay, already I have explained what is the scheduling. Okay, and what is the scheduler I have explained, dispatcher I have explained. Okay, so what is the scheduling? When the process are waiting in the ready queue for the execution, means the process are waiting for the CPU. Okay, then operating system dispatcher will select, scheduler will select one process from the ready queue and it will load into the processor. That is called as a scheduler. Okay, so here we have a different algorithms for a CPU scheduling. Okay, here we have a different types of algorithms to check the CPU, means it will is used to maximize the average time. Okay, that later will explain. But here we have a different types of CPU scheduling algorithms. But which algorithm is best is you can judge based on the scheduling criteria. Okay, so in order to select the best algorithm, means we'll select the best algorithm based on the scheduling criteria. Okay, so here we have a different types of scheduling algorithm and which algorithm is best, then we'll decide based on the scheduling criteria, right? So here in the scheduling criteria we have a different things here. First one is a CPU utilization, next to throughput, the third one is a turnaround time, fourth one is a waiting time, and the fifth one is a response time. Means in order to select which algorithm is best, which is giving a average time, the best average time, you can select, you can decide based on the scheduling criteria. Okay, so here why we are using the schedule criteria? To select, to judge which algorithm is best scheduling algorithm. Okay, to decide that, here we are using a CPU scheduling criteria. The first one, under scheduling criteria, we have a different factors. The first one is CPU utilization. What is the CPU utilization? Using a CPU, that is a CPU utilization. So in order to, the main objective of algorithms is the maximum utilization of CPU. Means that algorithm should keep the CPU as it should keep the CPU as busy as possible. Means the CPU should not be idle. Always the CPU should be busy. Okay, but the range of the CPU busy is it's from 0 to 100. But in real time system, the CPU is busy from 40 to 90%. But always the 100%. The CPU should be busy. So whatever algorithm you are selecting, that algorithm should keep CPU busy always. Okay, as busy as possible. That will come under CPU utilization. What it means, whatever algorithm you are going to select, okay, that algorithm should keep your CPU always busy. The second one is the throughput. Throughput here is nothing but it is a measure of the CPU work. It is a measure of the, underline this point, it is a measure of the CPU work. Means in a given time, how many processes are executed. In a given time, how many processes are executed. That is nothing but the throughput. Okay, this is the second criteria. Means whatever algorithm you are going to select, that algorithm means how many process it is executing in a 5 minutes, in a 2 minutes. That is nothing but the throughput of that algorithm. Now come to the third one, turnaround time. What is the turnaround time is? It is the how long, how much time it is taking to complete that execution. Means to execute that process. Means whatever algorithm you are going to select, that algorithm is how much time it is taking to complete its execution. Means to execute all the process. Example, 5 processes you have given. How much time that algorithm is taking to execute all those 5 processes. Okay, and when you come to this turnaround time, here you can calculate different waiting times. First one is how much time the process, all the process are waiting in a memory, waiting time in a memory. Next, waiting time in a ready queue, and waiting not execution time. Execution time. Complete this when you add this 3. How much time? Example, it is a 10 milliseconds. This is nothing but the turnaround time. Means a process, how much time the process is waited in a ready queue, in the memory. Okay. And how much time it is executed. That is nothing but the turnaround time. When the process is entered into a memory, or when the process is entered into a ready queue to execute, and it is waiting for a processor. That waiting time is also, means it will also come under the turnaround time. Means starting to ending. How much time the process is waiting and how much time the process is executed. Everything will come under the turnaround time. Okay. The next one is waiting time. What is the waiting time is? Example. Turnaround time already have explained. But here, waiting time, it will affect the performance of the algorithm. Example, if any CPU, if a CPU is taken execution time like 5 milliseconds. If it is more also, it will not affect the performance of the algorithm. Means the execution time, if it is more also, it will not affect the algorithm. But if any algorithm is taking more waiting time, okay, if any process is waiting more, okay, more time it is waiting, it will affect the performance of that algorithm. So what it means, if you are selecting any algorithm, that algorithm is making the process to wait for more time, that will not an efficient algorithm. So whatever algorithm you are going to select, that should minimize the waiting time of the process. Okay, now come to the next one, response time. Response time is also one of the measure of the algorithm which you are going to select. What is the response time actually? Example, you are asking one question. I am taking a 2 minutes to give answer to you. That 2 minutes is called as a response time. Okay, so actually this response time maximum will use in a real-time systems. Means whenever the process request is arrived inside, and when the first response is provided to that process, that is nothing but the response time. So whenever you are selecting any algorithm, that should satisfy all these 5 factors, and this will come under the scheduling criteria. So scheduling criteria, the first one is the CPU utilization. Means whatever algorithm you are going to select, it should always make the CPU busy. That is the first factor. The second one is the throughput. Means in a given time, how many processes are executed. Means how many processes that are executed inside the CPU, that will come under the throughput. And next is turnaround time. Means turnaround time is when the process is entered into a ready queue. And how much time it is taken for the execution, the complete time when the process arrives into the ready queue, and when process completed execution, whatever that time is taken for the execution, that will also come under the turnaround. Actually, that is a turnaround time. Now the waiting time means how much time the process is waited in the memory, in the ready queue, and in the execution. Actually, execution there is no waiting time. Execution time is also means waited. How much time the process is waited in the ready queue to get the scheduler, or to scheduler means how much time it is waited in the scheduler, and when it is loaded into a processor. That is nothing but the waiting time. The next, response time means when the user asks the question, or when the user when the user is given any request, and how much time that algorithm is taking to provide the response, that will come under the response time. These are the very important, because we have number of algorithms, 6 to 7 algorithms you have. All those 7 algorithms are based on this criteria only. Okay, you take screenshot of this. Now we'll discuss the different algorithms we are using now. Here we have different types of algorithms we are using. The first one is first come, first serve. FCFS. Okay, first come, first serve. Second one is shortest job first. Shortest job first. Next, the third one is longest job first. Fourth one is priority scheduling. Priority scheduling. Fifth one is round robin. All of you write down this round robin. Next, sixth one is multi-level queue scheduling. Multi-level queue scheduling. Next and the last one is multi-level feedback queue scheduling. Feedback queue scheduling. And one more point I want to tell you is, in your final exams, 100%, not 100%, 101%, you will get one algorithm from this. It's very important topic. 101%, you will get one algorithm from this. Okay? First you note down all the algorithms. I'll explain one by one. Okay? I'll give you 1 minute time. Note down all the algorithms. Don't take screenshots. You write down. Because it is very important. Okay? Because for each and every algorithm, you need to calculate average waiting time. Which is more means in the exam, you have to show that. So, in order to show that, you need to compare each and every algorithm. So, that is why you write down all the algorithms, and for each and every algorithm, we'll calculate the average time. Okay, you write down. Now, we'll discuss the first come, first serve. First algorithm we'll discuss. Okay. First come, first serve. In the name itself, we have a definition. Means, whichever process arrives first in the queue, that will be served first. Means whichever process is requested CPU first, that will be executed first. Okay. So whichever process requests the CPU first, that process will be executed. And it is similar to your queue data structure. Whichever process arrives into the queue first, that will be served first. And this process are mainly used in batch processing system, where more number of processes are waiting for a CPU. Here I will show you. Example, P1, P2, P3, P4. 4 processes are there. So here P1 is requested first for the CPU. Then P1 is first. Next, example, P3 is requested. P3. Next, P2 is requested. At last, P4 is requested. So, based on the time, they are arrived in the ready queue. It is called as the ready queue. Means the process are ready for the execution and they are waiting for the CPU. Example, this is the CPU. This is a CPU. Example, it is called as a processor. So whichever process is requested CPU first, that will be entered into a processor. Means first come, first served. Whichever process entered into a queue first, that will be executed first. Whichever process entered into a queue at last, that will be served at last. Clear? And one more point is here. If example P1 is executing inside the processor, inside the CPU, no other process can enter into CPU. When one process is inside the CPU in the processor, the other process need to wait. And after completing the current process, means after first process completes its execution, then only the second process will enter. It is non-preemptive. Means if one process is with the CPU, another process cannot enter into that block. Clear? Understood? So, first come, first serve. Whichever process is entered into a ready queue first, that will be served first. Whichever process is entered at last, that will be served at last. Clear? Now, here we'll calculate. Now, we'll calculate the average time, average waiting time of processor. Okay. Clear? Now here I will give the 4 process with the arrived time. Okay, with the burst time also I will get. Then you can calculate the average waiting time. All of you write down this. It is a step-by-step process. Example, it is a process. Next, it is a burst time. Burst time means the time is required to execute that process. Execution time is called as a burst time. Process. How many processes we have? P1, P2, P3, P4. All of you write down. You need to calculate the average waiting time. P1, 21, P2, 3, P3, 6, P4, 2. Execution time. And arrival time we are taking it as a 0 only. And one more is, in the same sequence, the process are arrived into a ready queue. Means first P1 is entered into a ready queue, next to P2, next to P3, next to P4. Clear? In the same sequence. Okay. Which process is entered into a queue first? P1. Next P2. Next P3. Next P4. You write down this. Now we will calculate the average waiting time. Okay. Now, we'll calculate the average waiting time. Actually, what is the average waiting time? As I said, for each and every algorithm, you need to calculate the average waiting time. What is the average? Means we'll compare the algorithms based on the average waiting time. What is the average waiting time? The waiting time of all the process in the ready queue. Okay, so what is the average waiting time? The waiting time of all the process. The waiting time of all the process in the ready queue is called as all the process, not only the single process. Okay, it is the waiting time of all the process in the ready queue. You need to calculate sum of the waiting process of all the process and divided by the number of process. Okay, understood? Now here we'll calculate the average waiting time of the process. How many processes are given? 4 processes. Now burst time. And what is the algorithm of in this algorithm how we are executing the process? First to come, first to serve. So in the previous table I have given 4 processes. Which one arrived first? P1 is arrived first. Next to P2, next to P3, next to P4. Clear? So here we have a Gantt chart. On that also you can present this. Example, how many processes we have? P1, next P2, next P3, next P4. Example. Here we have a CPU. Example, this is a processor. Okay. Understood? Now, what is the burst time of the example? Arrived time is 0. For P1, how much time it needs for execution? How much I have given? 21 I have given. It's 21. Clear? Now, P2. How much burst time of the P2? It is 3. So, 21 plus 3. 24. And so, how much, what is the execution time of the P3? It is a 6. Means 24 plus 6. It is a 30. Next, for P4, it is 232. 32 milliseconds, it is taking. Clear? So, P1 arrival time is 0, but execution time is 21 milliseconds. Next P2, it is 3, but 21 plus 3, 24. Total. Now, next here 6, 30, P4 execution time is a 2, so 32. To complete all the process, to complete execution of all the process, total how much time we need? 32 milliseconds we need. Here, what you need to calculate? Average waiting time of each and every process will calculate. Means waiting time of each and every process will calculate. Next we will calculate the average. Okay. First we will calculate the waiting time of P1. P1 waiting time is 0. Okay. Next P2 waiting time is, P2 is waiting till the complete execution of the P1. Okay. Now here the P2 waiting time is 21 because P2 is waited till the completion of execution of the P1. Next, P3 is waiting. P3 equals to how much? 24 because P1 is 21 and P2 is 3. Total 24. Next P4 execution time, P1 plus P2 plus P3. So completed is 30 milliseconds. Clear? P1 only 0 means P1 there is no execution, there is no waiting time. Now P2 is executed till the P1 completed its execution. So it is 21. Now P3 is waited till the P1 and P2 completes its execution. So that is 24. Now the next P4 waited in the ready queue till the P1, P2, P3 completes its execution. So that is why it is 30. Now we will calculate the average time of these three processes. Okay, means total how much time? Now 21 plus 24 plus 30. Actually the waiting time of the P1 is 0. Okay, you need to calculate this in the exam. It's compulsory. This you have 2 marks. This average waiting time. So 21 plus 24 is 55. 45. 45 plus 30 equals to 70 and divided with 4 because here we have a 4th process. So 75 divided with 4. How much you will get? Some 18.75. 18.75 is the waiting time. Clear all? It is the average waiting time. Clear all of you? So, same process burst time will take, same process execution time will take for each and every algorithm, and they will calculate the average time and will compare that average time with this average time. Based on that, you need to decide which one is best. Clear all of you? So, in the first come first serve, FCFS, what we are doing, whichever process is requesting for CPU, that will be executed first, and whichever process is requested CPU at last, that will be executed at last. Okay, means whichever arrives into the queue, that will be executed first. Understood? Now here if you want, here you need to calculate the average waiting time. What is the average waiting time? The waiting time of all the process in the ready queue divided with the number of process is the formula. Okay, now here we are here I have calculated the waiting time. For the P1 there is no waiting time. P2 the waiting time is at 21 because P2 is waiting till the P1 completes its execution. Next P3 is waiting till the P1 and P2 completes its execution. So average waiting time of the P3 is 24. Next average time of the P4 is, it's a complete execution time of P1, P2, P3. It is a 30. You need to calculate, means you need to calculate sum of all the waiting times and divided with 4. Because here, why we are dividing with the 4? Because here there are 4 processes. Okay, so that is why it is divided with 4. Total 75 divided with 4. What is the answer? What is the average waiting time? 18.5, 18.75. This is the average waiting time. This already have calculated once you go through that. Clear? So today what I have explained in this class, what I have explained, scheduling criteria. This waiting time is also one of the factor of the scheduling criteria. Already I have given waiting time. Okay, so whenever you are going to select any algorithm, first you have to check. What is the first criteria? The CPU is always, means that algorithm is keeping CPU is always busy or not. The second one is the throughput. Okay, the second one is the throughput. Throughput means in a given time how many processes are executing. For example, here if you have given only 30 seconds. The 30 seconds how many processes are executing? 3 processes. Example, one more algorithm is there that is executing 4 processes. Example, that is the throughput. And turnaround time is how much time it is taken for a process to complete execution, and which includes the ready queue time and plus execution time. That is called as a turnaround time. Next, waiting time. Waiting time is nothing but the time the process is waited inside the ready queue. How much time is waited? Okay, so how much after how much time the scheduler picks the process from the ready queue to for the execution. Understand? Response time. Means in a short, actually response time we use in interactive system only. How much time it is taken, means how much within a time, means it is taking a 1 millisecond or 2 milliseconds. How much time it is taken to give a first response to the user. That will come under the response time. Okay, so that are the scheduling criteria. So for next, based on scheduling criteria, we have a different types of algorithms in the CPU scheduling. So in the CPU scheduling, the first and the base algorithm is the first come first serve. Already I have explained, is whichever process enters into a queue, that will be executed first. So here I have calculated average waiting time also. Clear? Now we'll compare this average waiting time with the next one. What is the next algorithm? Shortest job first algorithm. That will continue in the next class. I hope you all understand. Okay, you note down this.